Hi and welcome to class 5 on number system. My name is Nishant and with me we have together covered 4 classes where we started with classification of numbers, rules of divisibility and summation of natural numbers in the first class. In the second class we did HCF and LCM related concepts. We also looked at few models for LCM and HCF. In the third class we covered all concepts related to factors. And in the fourth class, we looked at all concepts related to cyclicity, where we found the last digit and also the last 2 digits for any given number raised to any power. Okay. So now today we have come to the concept of factorial. Okay. Again, a very, very important concept. In fact, each of these concepts, if you see, is a chapter by itself and they give you so many questions. Factorial by itself is a small concept, but the number of questions and the variety of questions that can be formed on this is massive. So let's dig in right away, and I hope you're ready with your paper and pen, and I hope you have watched the previous classes and gone through the concepts and all, because all this is in continuation. We'll use some concepts of LCM, HCF as well. We'll use some other concepts. So in case you have not watched the previous classes, make sure that you go back, watch them and then come to this class. Okay. So let's jump right into the topic and understand what is a factorial. Now, factorial is nothing but a very simple concept. Factorial of a number is the product of natural numbers starting from 1 up to that given number. As simple as that. So if you have, let's say, why is it jumping? Okay. So if you have, let's say 10 factorial, then 10 factorial is nothing but 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 into 10. You can write from 1 to 10 or you can write from 10 to n. That does not matter, but this is what is 10 factorial. Factorials we always find for natural numbers. You can also, if required, mention that 0 factorial is equal to 1. Okay, 1 factorial is 1, 0 factorial also, if it comes to ever, it is taken to be equal to 1. Otherwise, factorials normally we find for natural numbers. There are no factorials for negative numbers. Okay, so that's all that is there in factorial. Now, what kind of questions are asked? The most common question is, what is the highest power of any number p that can divide n factorial? For example, 10 factorial I have already given you. I can ask you a question that 10 factorial can be divided by, let's say, 3 to the power x. What is the highest possible value for x? That is the question. Okay, so now this p that is dividing, it can be a prime number or it can be a composite number. Let's first look at prime number. So we have taken 3. Okay, 3 is a prime number. Okay, so if I do this manually first and later I introduce you to the formula, let's count how many 3s are there. So there's a 1 3 here. Then 6 also has a 3 and 9 has 2 3s, right? It is 3 into 3. So total you can see 3 has a 3, 6 has a 3, 9 has 2 3s. So together it is 1 plus 1 plus 2. There are 4 3s. Hence 10 factorial should be divisible by 3 to the power 4, right? So the answer would be 4 is the highest power of 3 that can divide 10 factorial. Okay, so that is how we can find this. So this is the manual method. But of course, if this was not 10 factorial but 100 factorial, then you would not have been able to count it manually. So we use a small formula or a small method to find this. And that method, let me explain to you, then I'll come here. Let's say it is 10 factorial. I divide it by 3. Okay, so forget the factorial. You basically divide 10 by 3. So every third number will have a 3. So then you write the quotient, okay, and don't bother about the remainder. So 10 divided by 3, your quotient will be 3. Okay, so there will be 3 3s of first layer. Where are these 3s? 3 has a 3, 6 has a 3, 9 also has a 3. Okay, so these are first levels of 3. Then I divide 10 by 3 square, which means 9. And this will give me numbers which have a second 3. And this will be every 9th number. So 9 will have 2 3s, 18 will have 2 3s, 27 will have 2 3s. So 10 divided by 9 will give me a quotient of 1. Okay, and then I can also divide by 10 to the power 3 cube, but this will give you a value lower than 1, hence I can ignore this. Okay, so 10 divided by 3, it gives you 1, 3 in 3, 6 and 9, and 10 divided by 3 square, which is 9, gives you 1, which is 9. Okay, 9 is coming twice. Why is 9 coming twice? Because 9 has a first 3, 9 also has a second 3. So 9 has 2 3s, hence 3 plus 1, you get 4. Okay, so this is how you do manually, and if you see, this formula tells you exactly that. You basically divide n by p, then n by p square, then n by p cube, n by p to the power 4. You keep doing this till you get a value lower than 1, and then you can ignore this, and in each one you just take the quotient. Okay, you just take the quotient. Okay, so let's say that I want to know 100 factorial. 100 factorial can be divided by what highest power of 3. So first what I'll do is 100 I will divide by 3, I'll get 33. Okay, then I will divide 100 by 3 square, which is 9. How much will you get? 11. Then you divide 100 by 3 cube, which is 27. 27, how much will you get? 3. Okay, and then 100 you divide by 3 to the power 4, which is 81, you'll get 1. Once you get 1, then you can stop, because the next one is going to be less than 1. So total value that we have got is 33. Now these 33 numbers, remember, also understand which are these numbers. So these are all numbers which are multiples of 3. 3, 6, 9, 12, up to 99. Okay, then these 11 are numbers which are multiples of 3 square. That means multiple of 9. So they'll be 9, 18, 27, up to 99. Okay, then these 3 numbers are numbers which are multiple of 3 cube, which means multiple of 27. So there are only 3 such numbers: 27, 27 into 2, 54, 27 into 3, 81. And these one number is a number which is a multiple of 81. There's only one such number, 81. Okay, so basically this one counts first layer of 3, first power of 3. This one counts second power of 3. This one counts third power of 3. This one counts fourth power of 3. So total 33 plus 11 is 44. 44 plus 4 is 48. So 100 factorial can be divided by 3 to the power 48. I hope we are clear till here. Okay, I'll give you a simpler method than this to solve this question. Okay, there's a simpler method which is a modification of this method only, but very useful. Understand this carefully. 100 by 3, then 100 by 3 square, then 100 by 3 cube, and then 100 by 3 to the power 4. They're slightly complicated because 100 by 3 square 9, you'll have to think, okay, it will get divided 11 times. 100 by 3 cube, all this is not required. This is a simpler method. Divide 100 by 3. You get 33. Now 33 is already 100 by 3. Divide this by 3. This will give you the second 3, which is 11. 11 by 3, you get 3. And 3 by 3, you get 1. So this is continuous dividing. So you don't have to really take power. This, if you see, effectively is 3 square, because 33 has already got divided by 100 once, and then you are dividing it again. So this is second division. So this is equivalent to dividing 100 by 3 square. This is equivalent to dividing 100 by 3 cube. And this is equivalent to dividing 100 by 3 to the power 4. Okay. So your answer will be, you won't count this 100, everything after that. So 33 plus 11 plus 3 plus 1, which will again give you the same value, 48. So this you will find easier to do. Let's say the question is 100 factorial can be divided by what highest power of 2. So what I'll do now with this method, 100 by 2 is 50, 50 by 2 is 25, 25 by 2 is 12. Don't bother about the decimal part or the fraction part. Okay, 12 by 2 is 6, 6 by 2 is 3, 3 by 2 is 1. And you stop when you get 1. So you get this much, which is 50 plus 25, 75, 85, 87 plus 10, 97. That means 100 factorial can be divided by 2 to the power 97. Okay, so I hope we are clear till here. Now so far if you see, we have taken prime numbers as the divisor. Okay, what if the number is not prime but a composite number? Then there is a formula which we call as Legendre's formula. This is nothing new formula. It is, we have discussed factorization in our factors class. It's very similar. So let's say we want to find out what you have a number 6 factorial, let's say. Okay, and 6 factorial, if you want to find out it will be divisible by what highest power of 2 or 3 or 5 or anything, you basically factorize the numbers. Okay, so 6 factorial is equal to 1 into 2 into 3 into 4 into 5 into 6, which is 720. And then 720 you factorize, and the factors that you get is 2 to the power 4 into 3 square into 5 to the power 1. Okay, so the exponents V2, that means V2 6 factorial, that means 6 factorial has 2 number 4th power. Okay, that means it can be divided by 2 to the power 4. Similarly, 3 in 6 factorial is present 2 times. That means it can also be divided by 3 square. And 5 in 6 factorial is present 1 time. That means it can also be divided by 5 to the power 1. Okay, so this uses a factorization method rather than division method, but I will prefer this anytime. This is a easier and a simpler method, and this is what we will stick to. Okay, but this is for prime number. What if we talk of composite number? We'll come to that. Meanwhile, let's just solve a couple of questions. Okay, so find the highest power of 7 that can exactly divide 780. Okay, so using what we had discussed back, 780 divided by 7 will give you how much? 1, 1, 1. Okay, now you can do 780 by 7 square, which is 49, but this will be complicated. 780 by 49, why do that? We'll skip this and we'll do 111 divided by 7. Okay, so 11 goes 1 times, and then you have 41. 41 will go 5 times. Okay, then 15 by 7 is 2, and 2 by 7 is 0, so you don't have to take that. So basically what you get is 111 plus 15, which is 126 plus 2, 128. So answer will be 780 factorial can be divided by 7 to the power 128. Okay, so this is the answer. Very, very simple solution. As you can see, you do continuous dividing rather than dividing by 7 and then 7 square and then 7 cube and then 7 to the power 4, which makes no sense. It will be complicated either way. You'll have to find powers of 7 also, and then you'll have to actually divide. Whereas 1 by 7, it's so much easier to divide. Okay, so this is the method that will follow. Your answer is 7 to the power 128. Okay, hope we are good till here. Okay, let's move forward. What if now P is a composite number? So P is a composite number which is the product of 2 prime numbers. Okay, for example, I want to know 100 factorial can be divided by what highest power of 6? Okay, this can be one question. And second case is P again is a composite number in the form prime number to the power m. Now both the cases you can take together. Don't worry about them. I'll tell you both, but both cases are similar. So basically there are only 2 cases where P is a prime number and second where P is a composite number. P prime number we solved, and now we will look at P as a composite number. So 1 is prime and 2 is composite. Composite has further these 2 parts, but basically they can be looked at together, and I'll tell you how. So let's say we have to find out 100 factorial is divisible by what highest power of 6. Now it will be a mistake if you look for powers of 6. So if you do 100 factorial 100 by 6, which will get 16. 16 by 6 is 2. So you tell me the answer as 16 plus 2, 18. This is a wrong approach, because the method that I told you in the last slide, that applies to prime numbers, and not to composite numbers. And why, you will understand very soon. So basically 6 is a product of 2 into 3. So for a 6, you don't really need a 6, you need a 2 and a 3, right? So 100 factorial, in the last slide we found out, has 2 to the power 97, it has 97 powers of 2. And we also found out that 100 factorial has 3 to the power 48. These were the values that we wrote, right? 2 to the power 97 and 3 to the power, somewhere we had written 48. 33 plus 11, 44, 47, 48. Right? So now if you see, it has these. So now how many pairs of 3 into 2 can you make? Your pairs will be equal to whichever is lesser. So you can see that 3 is lesser. 3 is present 48 times. So 2 also you will utilize 48 times. There is more 2, but you can't do anything with the remaining 2s because there is no 3 left. So 6 to the power 48 is what you can have. So your answer will be 6 to the power 48 and not 6 to the power 12. Okay. So this is going to be the answer. Okay. And as a rule, remember one more thing, that as the value goes up, its frequency will reduce. So 100 factorial has 297 times. It has 348 times. If I check for 5, 100 factorial has how many 5? 100 by 5 is 20. 20 by 5 is 4. And 4 by 5 will give you 0. So it has 24 5s. So can you see? 2 was present 97 times, 3 is present 48 times, 5 is present 24 times. So as the value, as the prime number becomes bigger and bigger, its frequency becomes smaller and smaller. So what you need to do, if the question is about 6 you know is 2 into 3, 3 is going to be lesser available than 2. So actually you don't need to check for 2. You just check for 3, and whatever is the availability of 3, that will be your answer automatically, because 2 will be more than that. For example, if the question is 100 factorial can be divided by what highest power of 10? Okay. Now 10 is 2 into 5. You know that 5 will be present less than 2. So you don't have to check for 2. You just check for 5. And 5 I know is present 24 times. So 10 also you can make 24 times. So answer will be 10 to the power 24. Automatically. So always you need to check only for the highest value. You don't need to check for anything else. Okay. The second variety which is given here, again as I told you, it's not different, but let's say now the question is 100 factorial is divisible by what highest power of 27? Okay. Now 27 again is a composite number. But one unique thing about 27 is 27 is power of a prime number. So it is 3 into 3 into 3, right? Unlike 6, which was 2 into 3, or 10, which was 2 into 5, 27 can be written as 3 to the power 3. Okay, that's the only difference. So 3 I know is present 48 times, right? So 3 is present 48 times. So now if I need 3 to the power 3, then this will be present how many times? 16 times, because 16 into 3 is 48. Okay, so 3 to the power 3 is present 16 times, or 27 is present 16 times. Hence the answer is going to be 16. 100 factorial can be divided by 27 to the power 16. So that is the only difference. Otherwise both of them are very, very similar. So when it's power of a prime number, you are not really looking for 2 or 3 different numbers. We are looking only for one number, but one number raised to a power. Similarly, if the question was 100 factorial is divisible by what highest power of 16, let's say. 100 factorial is divisible by what highest power of 16. Now 16 you know is 2 to the power 4, right? So we know that 2 is present 97 times. So if 2, let me write here, 2 is present 97 times, or you have 2 to the power 97, then 2 to the power 4, this you have to multiply now 4 with something that gives you 97 or lower than 97. You can't get 97, so you'll multiply with 24. 24 into 4 will give you 96, and there'll be one more 2. But this again, this 2 will be left alone. It will be of no use to me because it cannot make a 16. So 2 to the power 4 is present 24 times. Okay, so the answer will be 16 to the power 24. Okay, this 2 is extra, similar to when you're doing 6. These 2's were extra. There were so many 2's that were extra. When you're doing 10, there were so many 2's that were extra. Similarly, this 2 is extra in this case. So that's all. That is all the concept that is there for composite number. So what did we learn? In a composite number, break it down into prime factors and check the power for the largest prime factor. That's all. And that will be your answer. Okay, great.